All right, welcome. This is the IM2 Distance Learning Packet tutorial and solution. Here we have week 2, which is the dates of April 13th through the April 17th. Here we have page 4, 5, and 6. It's all together, okay? It deals with this performance task, all right? So let's take a look, okay? So Marco started a new blog about this image and he created this logo. Size 1, size 2, size 3, size 4. Okay, if he continues this pattern, how many squares would they be at the 100th logo? Alright, very easily. Just start counting. Alright, so I'm just going to count. Okay, zoom in. Let's just count. Alright, 1, 1, 2, 3, 4, 5, 6, 7. So here, there's 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here there's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22. All right, now we would like to see the 100th logo. So we're going to continue this, but there has to be a pattern. Okay, so how do you go from 7 to 12 to 17 to 22? It looks like you are adding by 5, adding by 5, adding by 5. So to continue on, you are going to what? Keep adding by 5s. Alright? So you want to continue this up to the 100th logo. Okay? Um, so there's a lot of ways you can do this. So at the 5th logo, let's see, it would be at the 5th logo, it would be 25, right? Reason. All right. So again, you could figure out how many that you need to get the 100th logo. I'm gonna figure this one out after I do number 2. Okay. Number 2 asks you to develop a mathematical model for the number of squares in for the size n. Okay. So the fact that it's adding should remind you of this. This is referred to as a arithmetic sequence. So let's look at the notes. Okay? Each term that it's going up, it's adding. If it's adding, it's called common difference. It's called an arithmetic sequence. The formula for an arithmetic sequence, if you continue, looks like this. All right? But I actually don't like this. What I like doing is so you could write this as one of the answers, right? So here an acceptable answer would be an is equal to a1 plus n minus 1 d. But your a1 is referred to your first term. Your first term is 7. Your d, which is your common difference, is 5, right? Okay? So what you have to do is take this a1 out, okay? Put in the number 7. Then your common difference is going to be 5. Okay? This is one way of doing it. And then for the 100th logo, all you have to do is you plug this in. So let's just take a look of how that would look like. So I can move this here, right, for you. For your 100th logo, the 100th logo would be when n is equal, for the 100th logo, that is when n is equal to 100. So plug it in. A of 100, right? You see n. 7 plus, put in 100 for the n, minus the 1 times the 5. So this becomes 7 plus 99 times 5. Okay, which is equal to, grab decimals, 7 plus 99 times 5. So it would be 502. Okay? That would be at the 100th logo. All right? Because again, it's an arithmetic sequence. But for me, this is the way it's normally taught. Okay? And that's all. That's all you could do. If you don't want to hear me explain this a different way, you can just fast forward, okay? But I'm going to show you the way I do it, okay? The fact that this is an arithmetic sequence, it behaves like a linear equation, all right? So I know it should behave like a linear equation, all right? Which is y equals to mx plus b. Good? B is my slope. The slope here, it goes up by what? 5 each time. So this should be 5. My m is equal to 5. What is my starting value? This is when y equals to 0. Do you have this? No, you need to have size 0. Do you have size 0? Well, you sort of do, right? You remember, to get to here, you had to go plus 5, right? So what is this number? What number add 5 to get you 2? That's 2. Okay, 2 add 5 gets you 7. So my starting value here, you would say that b is equal to 2. So I can just write this equation. Y is equal to 5x plus 2. This would be valid for here. Okay? The hundredth logo is when x equals to, now you are going to get let x be equal to 100 for the 100th logo, right? So y equals to 5, parentheses, plug in the 100, plus 2. 5 times 100, 500, plus 2, y equals to 502. See? Same thing, right? A lot of people memorize the arithmetic sequence. I actually don't care. You already know y equals mx plus b, so just use y equals mx plus b. You know what slope is. Slope is the equivalent to this idea of a common difference. You just have to make sure you get the 0 term. Okay? Alright? But this is only for an arithmetic sequence, okay? So let me just move this up because we got to do the other ones. Alright? What about this? He decides to do this. Let's count this. Alright? So 1, 2, 3, 4, 5, 6, 7. So 7 here. Let's count. Ooh, this is hard to count. So this is 4, 4, 4, 4, 4, 4, 4. So how many fours are there? 1, 2, 3, 4, 5, 6, 7. 7. So this is 28. All right. What about this one? Uh, let's see. 3. That makes 9, right? That's 9, 9, 9. I'm just speeding up my counting. 9, 9. This is what I'm just doing. I'm just counting these. 9, 9. How many nines are there? 1, 2, 3, 4, 5, 6, 7. 7 times 9 is what? 1, 2, 3, 4, 5, 63. All right. So how do you go from 7 to 28 to 63? There's no way you're adding. Okay. But you could almost see it. Right. Okay. You're actually what? Multiplying. From here to here, you are multiplying by 4. How do you go from here to here? Right? 63. Let me just double check to make sure this is right. Let's pull up Desmos. Okay. 63 divided by 28. Hold on. That doesn't work. Because 28 divided by 7 is 4. Ooh, did I miscount this? Hold on. 1, 2, 3, 4, 5, 6, 7. This is 7. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4, 4, 4. 1, 2, 3, 4, 5, 6, 7. So 7 times 4 is 28. So this is 28. What about this? This is 9. 1, 2, 3, 4, 5, 6, 7. 9 times 7 is 63. So this is 63. Oh man, this is brutal because look, 63 divided by 28 is that 28 divided by 7 is that? Oh, this is not geometric. Oh, I thought it was geometric. Uh-oh, it's not geometric. This is interesting. This is very interesting because now it says draw the next four figures. Exponential? Do you want this to grow exponentially? Okay, hold on. Give me 1 second to think about this, okay? Okay, so this is wrong. It doesn't multiply by 3. It doesn't multiply by 4, right? So this is bad, okay? But we could sort of figure out how it's going to look like. Because look at the first shape. How do you go from here to here? It seems like each block, watch this. It seems like this is the first block, right? It seems like they add this, and this to the first block, right? The middle block, same thing. If this is the middle block, do you see how they added? So it seems like they added this piece to it. Same thing here, right? The far right, they added this. So they added that. Okay, same thing for the bottom. So this one, the next one should look something like 1, 2, 3, 1, 2, 3, 1, 2, 3. So originally it should have 3, right? 1, 2, 3. One. Screw this, dude. I forgot I have paint. So originally it should look like this, right? So 3, okay? Right? It had 3, right? So do you see how originally it had 3? Okay? So all you do is gonna add this. So now it becomes a 4 by 4. Then the middle one also becomes a 4 by 4. So 1, 2, 3, 4, 4 by 4. The top one also becomes a 4 by 4. So 1, 2, 3, 4, 4 by 1, 2, 3, 4, 4 by 4. Good. Right? The middle one here becomes a 4 by 4. So 1, 2, 3, 4, a 4 by 4. All right? Yep. So this was a 4 by 4. This is a 4 by 4. This is a 4 by 4 as well. Okay, so 4 by 4, 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 4 by 4. Okay, so, right, you see how this was a 1 by 1? This is a 2 by 2, 2 by 2, 2 by 2. Each one of these are 2 by 2s. Here, these are 3 by 3s. Okay, what I mean by that is this is what I mean. So, this was a 2 in the right? This was a 2, and this was a 2. Here, this was a 3, this is a 3. So here, do you see how each box is a 4? This box is a 4, right? Each one of these is going to be 4 by 4, right? That's what it means. 4 by 4, 4 by 4, 4 by 4. The area is 4 by 4. Okay? Draw a mathematical model for this block. Oh my gosh. Oh. So the first term is the first term is basically a 1 by 1. Okay? Right? The first term, right? Size 1 is basically a 1 by 1. Size 2 is going to be a 2 by 2. Right? Size 3 is a 4 by 4. Size 5. Alright. Nope. So, sorry. This size 3 was a 3 by 3. Size 4 is going to be a 4 by 4. We know that. Okay? So this was basically So this is size n is going to be n times n or n squared, right? But how do they get this number of 7 though? Do they do 7, so how do, okay, so here it makes 4, then this is going to multiply by 7, right? That how, okay, so check this out. So the first one, it was 1 squared, right? How do they make 7 though? You multiply this by 7. That's why the total was 7, right? Was your total. Same thing here. This is a 2 squared, right? This became 4. How many 4s were there? 1, 2, 3, 4, 5, 6, 7. 7. So 4 times 7 is equal to 228. That was your total for your third one. Okay? Your second one. Your third one, 3 cubed times 7. So 3 cubed was 9. We multiplied that by 7 times. So that was 9 times 7 is 63. We wrote that was your total. Here, this is 4 times 4, which is 4 squared, times 7 is 4 times 7. No, sorry, this would be 16 times 7. 16 times 7, let's just grab decimals for that. Okay. What did I want to do? 16 times 7. So 16 times 7 is 112. So this was equal to 112. Oh, haha, I get it now. 112, that's your total. So the model, it's n squared times 7. The n squared times 7, okay, is going to be equal to your total blocks. All right? This, so compare the model that you developed for the first. So this is the size of the block. This is how many blocks. Okay? So compare the model that you developed in your first set of logos, the first one and versus the second one. Well, that's easy. Well, the first logo, we um the person, wait, is there a name for him? What's his name? uh what's his name? I should probably write his name. Marco. Okay, so for the first one, um compare the model. Well, for the first one, for the first logo, Marco added 5 square boxes to um, each new size. All right. Okay. Then the next one. All right. The next one, the second logo, Marco. Let's see. Increase the size of the box. Okay. By um, squaring it. By doubling it. You wouldn't say doubling it, by squaring it. Okay. Is that how you spell squaring? Squaring it. Square. Squaring it. I feel like there's an E. Yeah, whatever. So, there you go. Alright, well, how are they different? Well, they are different by the size. The first logo is smaller. The second logo is larger. There you go. Alright. Is that it? Is that all the problem? Is that it? Really? Okay. Um, give me a second to double check if that's it. Yeah, that's it. So I had notes on geometric, but it's this one is not geometric. It's I don't even know what you would call this. Exponential probably because of this. So there's probably a neater way of writing this. I know what they did. This is probably yeah, exponential. So log probably, right? So okay, cool. Yeah. Interesting lesson. This is a very interesting lesson. Actually made me think here, right? So there you go. Hopefully that this intrigued you as much as I did, all right? But there you go. Those were all your solutions.